I have decided to put more than just one of these secant, cosecant, cotangent type problems on here. Two of them are, however, multiple choice, so there will be a little bit of support there. I have also decided not to put anything in there like cosecant squared minus 1, where we have to do a lot of building of common denominators. I'm going to save that for a later time. So focusing right now on how to get this style problem done on the unit assessment. As we've discussed in class, the idea behind simplifying all of this is to simply convert everything using the properties that we have into sine and cosine. So let's start with this one. We've got, well, in the numerator we have sine squared. No conversion there. Sine squared of theta. Cosecant of theta. Now, cosecant of theta is going to be a relationship that is established with, let's write out a table, sine secant, tangent cotangent, fill in the missing stuff, cosine, and then this would be cosecant. All right, so cosecant is related to, here we go, cosecant is related to sine. So cosecant theta, all in the numerator, that's going to be 1 over sine. Now it looks like I'm multiplying fractions, so I want to put everything else in fractional form as well. Just makes things easier. The next item in the numerator is this secant of theta. Secant of theta can be expressed as 1 over cosine. That's the relationship. These are reciprocal. So 1 over cosine. Now that takes care of each one of these three that are in the numerator. And since we have successful conversions, let's go ahead and just move on down to the main numerator. And this time I'm going to put this one in blue. The denominator is tangent. And tangent, as we have also discussed in class, one of the two properties, one of them is 1 over cotangent. That doesn't really help because I want everything in sine and cosine. So I'm going to choose sine theta, cosine theta. Really doesn't help to put it into cotangent. So using this strategy, I can really approach each component of this fraction one at a time. Let's simplify it before we start trying to multiply everything out. At least that's my approach. If it works for you to switch everything around, that's fine too. So I'm going to rewrite the numerator. I'm going to put every... So again, just want to rewrite all of this. I'm going to take on the numerator first. Sine squared of theta, that just stays as is, that's over 1, times 1 over sine of theta, and then 1 cosine of theta. Those are the three elements that I have in my numerator. This can all be rewritten. Since I'm multiplying fractions, I can just put one great big fraction bar in there, and then all of these components get multiplied together. And in the denominator, those components get multiplied together. So let's rewrite. Here we have sine squared theta times 1, that stays just like it is. And then in the denominator, 1 times sine times cosine, of theta. And we've got sine theta, cosine theta. Now I notice that I've got a thing in the numerator. That would be sine theta squared, so I can rewrite it this way. I'm just doing this for illustrative purposes. Most of y'all have already seen this a few times. So I've now successfully rewritten the entire numerator, and I notice that I can factor out from both. Sine theta over sine theta becomes, that's the same thing as 1 over 1, or just 1. And I'm left with sine theta, squeeze that into, and then in the denominator, cosine theta. Okay, that takes care of the numerator. And put a little box around it so I don't forget. Working in the denominator, that's just, well, the denominator is already pretty much figured out. That's sine theta, cosine theta. And when you've got one fraction over another fraction, which is what we have at this point, let me just tell you what, let's rewrite all this. Since that really doesn't change, we don't have to do anything to it. So I'll free up a little bit of space. Okay, back in the numerator, this thing right here, let's put that back in the top. So we have sine theta over cosine theta. That's the simplified version of the numerator. And then in the denominator here, we have sine theta over cosine theta. Most of you will now see that that's one fraction divided by the identical fraction, which would just be 1 over 1. But an opportunity to review the same thing or review this particular technique. When you have one fraction divided by another fraction, that is the fundamental equivalent of taking the numerator, in this case that fraction, and multiplying it by the reciprocal of what's in the denominator. So if I've got sine over cosine, I can multiply it by cosine over sine theta. Let's see. Sine theta times cosine theta over cosine theta sine theta. Everything is, nothing's added or subtracted. These are all multiplication or products, so I can divide cosine theta out of both, leaves me with 1 over 1, and then I can turn around and divide sine theta out of both, which leaves me with 1 over 1, and that in turn leaves me with a solution, 1.